Hello everyone, I hope you're doing well. In this video I want to talk about a theorem which is about the compactness. And this theorem goes in this way. Suppose K to be a subset of Y and Y to be a subset of X. Then K is compact relative to X if and only if K is compact relative to Y. Well, basically, if I want to make everything easier here, basically I have a metric space which is X, and I have a sub-metric space. I have a subspace which is Y, and K is a subset of Y. Okay? This theorem basically says K is compact relative to X if and only if K is compact relative to Y. But why is compactness relative? This is the question you may have. Look, when we're talking about the compactness of a set, we have to know that we're basically talking about the open covers. And when we're talking about the open covers, as you know, we know that the openness of a set is relative. Okay? So the compactness is going to be relative too. Okay, to prove this theorem, I want to begin with the hypothesis of K being compact in X and prove K is compact relative to Y. So let's write the hypothesis and the result here. Hypothesis. And let's assume K is compact relative to X. K is compact in X. Okay. To prove that K is compact in Y, I have to show that every open cover of K in Y is going to have a finite subcover. Okay. To begin with, I want to think of the collection of V alphas, V sub alpha, okay, to be an open cover for K, open cover for K in Y, okay? Then I'm going to show that this open cover is going to have a finite subcover in Y. Okay. Look, when we're talking about the open covers in Y, we're basically talking about the open sets in Y. And as you know, if we have an open set in Y, we can tell that there's going to be open sets in X, which V sub alpha equals to G sub alpha intersects Y. This is basically the relative openness theorem. Okay, and as you can see here, V sub alpha is a subset of G sub alpha. Okay, V sub alpha is a subset of G sub alpha. And I know that G sub alpha is open in X. Open in X. Okay, as you can see here, G sub alphas is going to be open sets relative to X, and V sub alpha is a subset of G sub alpha. So I can tell that G sub alpha, the collection of G sub alphas, is going to be an open cover for K in X. Open cover in X. In X. Okay, and from this hypothesis, I know that K is compact relative to X. Then it's going to have a finite subcover. Okay, so I can tell that K is a subset of union of G sub alpha sub I I begins from 1 and goes all the way to the end. As you can see, K is a subset of the union of G sub alpha sub i's. Okay? And I know from a fact that I know from the hypothesis that K is a subset of Y. I'm going to write it. K is a subset of Y. Okay? Then, from these two propositions, I can conclude that if K is a subset of one set, and again K is subset of another set, I can tell that K is the subset of their intersection of those two sets. Then K is going to be subset of the intersection of these two right-hand side sets. Union of G sub alpha sub I begins from 1 and goes all the way to the end, intersects Y. Okay? And as you can see, let me open it so it becomes a little bit easier for you. Okay? This set that I'm going to underline it, this set here, is basically this. G sub alpha sub 1 union G sub alpha sub 2 union goes all the way to G sub alpha sub n intersects Y. And I know from here that this set is going to be G sub alpha sub 1 intersects Y union G sub alpha sub 2 intersects Y and goes all the way the union of G sub alpha sub n intersects Y. Okay, so if I write it here, I'm gonna have K is a subset of the union of G sub alpha sub I intersects Y I to begin with n and goes all the way to the end. Okay, let me erase this so we can have multiple space to write the rest. Okay, and as you know from here, I'm talking about this set that I'm going to underline it. You know from here, G sub alpha sub I intersects Y equals to V sub alpha sub I. So I can tell K is subset of the union of V sub alpha sub I to begin from 1 and goes all the way to the end. Which basically means the collection of V sub alpha has a finite subcover. Okay? Which means the collection of V sub alpha has finite subcover. Okay. So I could prove one part of this theorem. And I'm going to go to the second part. I'm going to think that, and as you saw here, I thought of V sub alpha to be an open cover of K and Y, and I could find the finite subcover. Okay, so I could prove, one side of this theorem. And I'm going to go to the opposite side. Okay, I'm going to think K is compact in Y. K is compact in Y. Okay, and then I'm gonna prove that K is compact in X. Okay, to begin the proof, again, I have to prove that every open cover in X has a finite subcover. Okay, so I'm gonna think of the collection of G sub alphas to be an open cover for K in X. Open cover in X. Okay, so the collection of G sub alphas is going to be an open cover for K in X. Okay, and as I said, because G sub alphas are open covers, then there's going to be, open sets in Y. Open sets relative to Y, and I'm going to call it V sub alpha. Okay, then there's going to be V sub alphas, which this V sub alphas equal to G sub alpha intersects Y, and these V sub alphas are open relative to Y, open in Y. Okay, open in Y. Okay, what I'm going to basically have here is that V sub alpha equals to G sub alpha intersects Y, and V sub alphas are open in Y. Okay. Now I know that because this G sub alphas is an open cover in X, I can write K is a subset of the union of G sub alphas to alpha, and from the hypothesis I know K is a subset of Y. Okay? Then from these two propositions, I can conclude that K is also the subset of these two sets, these two right-hand side sets, intersection. K is a subset of the intersection of these two right-hand side sets. So K is intersection of the union of G sub alphas intersects Y, which I know from before. I proved it before that the set is the union of G sub alpha intersects Y, and I know from here that G sub alpha intersects Y is going to be V sub alpha. So K is the subset of the union of V sub alpha, and from the hypothesis I know that K is compact relative to Y, so it's going to have a finite subcover. Every open cover is going to have a finite subcover. So I can tell K is a subset of the union of V sub alpha sub I, for I to begin from 1 goes all the way to the end. Okay? But now I know that V sub alpha sub I is the subset of G sub alpha sub I. Okay? Which basically means if K is a subset of the union of V sub alpha sub i's, then for sure K is a subset of G sub alpha sub i's. So I can tell K is the subset of the union of G sub alpha sub i's, for I to begin from 1 and goes all the way to the end. Which this proposition means which this means G sub alpha has a finite subcover. So I can tell that because G sub alpha has a finite subcover, then K is compact in X. K is compact relative to X. Okay, this was basically all the proof, and I could, at the end, prove the opposite side. So let me write it. G sub alpha, the collection of G sub alphas, has finite subcover. Finite subcover. Okay? I wish you the best. Bye.